Write an overall equation for the reduction of butanone. So reduction is adding hydrogen to represent, using H with square brackets to represent the hydrogen that's being used as the reductant. So hydrogen's been added, and the way that we're going to show that is with a square bracket around the H. First of all, we need butanone, which is CH3, CH2, COCH3, and we're going to need two H's, because that CO, that ketone, that butanone, is going to be reduced into a COH and an H. So the C double bond O becomes a COH, and the carbon needs another H off it. Therefore, it becomes a secondary alcohol. So it becomes butan 2-ol. By considering the mechanism of the reaction, so how does it actually happen? So you can use a hydride ion, a H- ion, that's going to be a nucleophile and attack that C. That's the way it's going to go. It's going to attack the C, and then the pair of electrons on the double bond oxygen will go onto the O, and then an H plus, because it's probably in methanol. The H plus from the methanol will then bond on, so there'll be a lone pair of electrons on the O, which will have a minus bond onto the H plus. So how does that happen then to give a product that's got a plane polarized light? So first of all, the H minus is a nucleophile, so it's going to be a nucleophile and it's going to attack the C. This is planar, this is flat, so the CO is a flat. It's only going to have three bonds, a double bond to the O and a bond either side to either carbon, so it's only got three atoms bonded to it, so that's flat. It's not got four, it's not tetrahedral, so it's going to be flat. So the H, or the H minus, the hydride ion, can attack from the bottom or from the top. It can attack from above or below. That's going to create two different enantiomers, two different mirror images of each other in equal amounts, because there's an equal chance of attack from top or from bottom or from above or below. There's an equal chance of this hydride ion, this nucleophile, attacking from above or below. So that equal chance creates equal amounts of each of the two enantiomers, and that's called a racemic mixture, where you get 50% of each enantiomer. Therefore, there's going to be no overall optical activity, because each of the two enantiomers rotate plane polarized light equally, but in opposite directions. So therefore you're going to get no rotation of plane polarized light with a racemic mixture.